Hi, in this video we will find out what isotopes are by looking at the isotopes of the elements carbon and hydrogen. We will also look at the chemical and physical properties of isotopes and finally explain how to calculate the relative atomic mass of isotopes. To find out what an isotope is, let's start by looking at the element hydrogen. Now, all hydrogen atoms have one proton in their nucleus and one electron in their energy level or shells. All hydrogen atoms must contain one proton in their nucleus. If the nucleus does not contain one proton, then the atom is simply not an atom of hydrogen. It may seem surprising then that there are three different types of hydrogen atoms that occur naturally. These three types of hydrogen atoms are often called protium, deuterium and tritium, and their structures are shown on screen. Now, by looking at the three different types of hydrogen atoms, ask yourself, how are they similar to each other and how are they different? Well, each type of hydrogen atom has one proton in its nucleus and one electron in its electron shells or energy levels, but they differ in the number of neutrons present in the nucleus. Protium has no neutrons, while deuterium has one neutron and tritium has two neutrons in its nucleus. Now, you may have figured this out already, but these three different types of hydrogen atoms are called isotopes of hydrogen, and isotopes are simply atoms with the same number of protons in the nucleus, but they have different numbers of neutrons in the nucleus. Now, recall that the mass number of an atom is simply the sum of the number of protons plus the number of neutrons. So each of these atoms or isotopes of hydrogen will have different mass numbers, and this leads to a second definition for isotopes, that is, elements with the same atomic number but different mass numbers. Now, we can easily work out the masses for these three different isotopes of hydrogen and then write out the symbols for each of the isotopes. Now, recall, all hydrogen atoms have one proton, so their atomic number is 1. So protium has one proton and no neutrons, so its mass number will be 1, whereas deuterium has one proton and one neutron, so its mass number will simply be 2. And finally, tritium has one proton and two neutrons, so its mass number will be 3. The element carbon, like hydrogen, has three naturally occurring isotopes. Now, carbon is element number 6 in the periodic table, and so carbon atoms have an atomic number of 6, with 6 protons in the nucleus and 6 electrons in the electron shells or energy levels. The three isotopes of carbon, called carbon-12, carbon-13 and carbon-14, are shown on screen. The only difference between the isotopes of carbon is the presence of extra neutrons in the nucleus. The carbon-12 isotope has 6 neutrons in its nucleus, while the carbon-13 isotope has 7 neutrons in its nucleus, and the carbon-14 isotope has 8 neutrons in its nucleus. Now, you may recall that the chemical reactions of an element depend on the number of electrons in the last shell, and since all isotopes have identical electron arrangements, they will react in an identical way. This means it is not possible to use chemical tests to identify different isotopes in a sample. Now, as we have seen before, isotopes of an element all react in an identical way. That is, they have identical chemical properties, and this is due to the fact that isotopes all have the same electron arrangements. But isotopes of any particular element will have slightly different physical properties due to the differences in the masses of each isotope. For example, they will have slightly different melting points, boiling points, or densities, or indeed any other physical property which depends on the mass of a particular atom. As a simple example, consider methane gas, the gas used in Bunsen burners. Now, methane gas has a molecular formula CH4, and 3 methane molecules are shown on the screen. However, each of these molecules has a slightly different formula mass, since these molecules contain different isotopes of the elements carbon and hydrogen, and so these molecules will have slightly different physical properties due to the differences in their formula masses. Now, the relative atomic mass of an element recorded in the periodic table is the average mass of each isotope of that particular element, taking into account the percentage abundance or isotopic abundance of each isotope. That is simply how common the isotope is. As an example of how to calculate the relative atomic mass of an element, consider element number 5 in the periodic table, which is boron. Now, boron has two naturally occurring isotopes, boron 11 and boron 10. Boron 11 is the most abundant or common of the two isotopes, with 80% of all boron atoms having a mass number of 11, while 20% of boron atoms have a mass number of 10. Now, to calculate the relative atomic mass of boron, or the average mass taking into account the abundance, use the formula shown on screen. Here, the mass of each isotope is simply multiplied by its percentage abundance, and the result is then divided by 100. If you work out this sum, it will give a relative atomic mass of boron of 10.8. Hi, thanks for watching, and hopefully you found this video helpful. If you need more help or information on isotopes, then why not visit the website that accompanies these videos? The links are in the description below. If you enjoyed this video, then please consider liking and subscribing. Thank you.